Okay, so we will be adding, subtracting, and multiplying polynomials in this section. Okay, so it is a lot. I don't know for sure if we'll get through the whole thing, so we might wrap it up tomorrow. I don't know. Anyways, okay, so basically, obviously adding, subtracting, it's just like terms. You've been doing that for a long time, so that should be pretty simple. Okay, it will be stuff like in parentheses and then have like either an addition or subtraction symbol between the two. So it'll look probably a little different than you've done before, but the principle of it is still the same. Okay, but these are the multiplying ones. Okay, so the sum and difference, we've seen these a little bit before, okay, with factoring and stuff, but a plus b times a minus b factors into a squared minus b squared, okay, because that middle term, the ab minus ab would cancel each other, so it goes away. For the square of the binomial, okay, that's a plus b squared or a minus b squared. The only difference with these two is that the sign here matches whatever these are. So if this is positive, this is positive, this is negative, this is negative. Okay, so a squared plus or minus 2ab plus b squared. And then lastly, the cube of the binomial, we have a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And then basically the same thing for the other one, but these two signs are flipped. Do you guys notice a pattern in these? Reverse it, but yes. Okay, so a is in decreasing order, so it's a cubed, a squared, a. There's no a terms, okay? No b terms, b to the first, b squared, b cubed. Okay, so it follows that pattern, and the numbers is always 1, 3, 3, 1. Okay, it's a special pattern, and I'm blanking on the name right now. When it comes to me, I will tell you what it is, but it's off that special triangle. It's a big triangle thing, and I'm blanking on the name of it right now, but it will come back to me at some point. It might be called, I just can't think of the name of it right now, but I literally have a poster for it, so just, when I find it, I find it. But anyways, it's a triangle that follows a pattern. Okay, the triangle follows a pattern that looks like this. Okay, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, and it goes down and it keeps going to infinity. It's basically these two numbers add up to give you this one, and there's always ones on the outside. So these two numbers add up to give you this, these two add up to give you this. So it keeps going and it follows a pattern. Okay, you don't have to know the triangle, I'm just explaining it to you. Eventually it might come in handy to know that, but anyways. That's where this pattern comes from. That's why it's 1, 3, 3, 1. Okay, anyways. That's that. So, moving to examples. So first, adding and subtracting polynomials. We're just going to start moving through this, and we'll just see how much we get through. Let's start with 4. X squared minus 3x plus 5. All in parentheses minus, another parentheses, negative 4x squared plus 8x plus 9. Okay? So, big things you have to pay attention to is knowing that this sign, whatever it is, goes to every single piece here. A lot of times people just want to stick it on this first one and they forget that it goes to every single piece in it. Okay, so some people like to rewrite it and go ahead and change it. If you want to rewrite it so you don't mix stuff up, that's fine. If you just want to do it without rewriting it, that's also fine. Okay, so basically I'm just subtracting like terms here. So, any ideas what this one would be? Okay, 5x squared, okay, because we have x squared minus a negative, so that becomes positive, so x squared plus 4x is 5x squared. Negative 11x, okay, so negative 3x minus 8x, and then 5 minus 9, somebody said was negative 4. And you're done. Um, 8. 2a squared minus 8, and then minus a cubed plus 4a squared minus 12a plus 4. Alright, so again, we have a subtraction going on here, so you need to make sure we pay attention to that it goes all the way through. So combined like terms, what do I have? Negative a cubed. Okay, there's no a cubed terms over here, but I still have to make sure that negative gets with that, so that was good. Minus 2a squared plus 12a minus 12. Okay? Everybody agree? Good. Okay. 12. 3y squared minus 6y to the fourth plus 5 minus 6y plus 5y to the fourth minus 6y cubed plus 4y. Me and Lorelai, we got several 5s in this one. Alright, so this one we are adding, okay, but we still have to pay attention, obviously, to the signs that are on each individual piece. But we're adding, so this one is probably a little easier. So, yes, your answer needs to have them in order. But you don't need to reorder these to do that. So we always want our terms in descending order, okay? So we always want the biggest term first, smallest term last. So, wait, what did you say? I didn't hear the negative, that's why I wanted to check. Okay, everybody agree here? Make sure you took care of everything. Alright, so you guys are going to try this one on your own. 8v to the fourth minus 2v squared plus v minus 4 minus 3v cubed minus 12v squared plus 8v. Alright. Do we have an answer? What do we get? Yep. 8v to the fourth minus 3v cubed plus 10v squared minus 7v minus 4. Alright, we good on adding and subtracting? Yeah. Cool. Let's multiply then. Alright, 16. X times 2x squared minus 5x plus 7. So how does this work? Okay, distribute. So what do I get? Alright, 18. Y minus 7, y plus 6. FOIL, so what does that give us? um, 20. W plus 4, W squared plus 6W minus 11. Okay, basically we're super foiling here. Okay, essentially you just FOIL until there's nothing left, okay? So I always go first piece times each of them, and then I go second piece times each of them. Okay, so it's like a super FOIL. Yeah. Okay, and then simplify it. Alright, are y'all ready to try one? Alright, I want you guys to try this one. 5c squared minus 4 times 2c squared plus c minus 3. Yeah. Yeah. No. No. Not this stuff. If this stuff makes you cry, then you're not going to want to go much farther. I even gave you one that has a 5 in it. What? I was going to say, I heard 50 plus 8, and I was very confused about where a 50 came from. I think it's like the extra energy from eating.
Oh, yeah, probably.
In study hall? Alright, do we have an answer then? Go for it. Everybody agree with her? The 23rd power of c squared. Alright. Are y'all ready to super foil? 5c squared times c. Alright, 24, negative d squared plus 4d plus 3 times 3d squared minus 7d plus 6. Yeah, now we're super foiling. So it's going to be each piece raised. So you should have 9 terms by the time you're done. Okay? So we'll walk through this one together so we don't lose pieces. Alright, so somebody tell me what to start with. Go. No, we are. $62. Oh. I was like, we have 50 and 8, and we have 62. Okay, when there's this many terms, you might want to consider, like, marking stuff out as you've done it, just so you don't forget pieces. Okay, don't, like, erase it or something like crazy on your paper when you go to do it, because then I can't see what you did, but. Huh? So we had negative 6d squared, we had negative 28d squared, and we had 9d squared. Yeah, so that's why also sometimes it does benefit. I don't know if y'all did it this way, but like when I was taught about adding like terms, for every variable that there was, we put that many lines under it, and then we grouped everything with that afterwards. So if you're good with doing it this way and you don't forget terms, that's fine. But if you want, we would always do that, And then we would group things that had the same amount of lines together. So that way we wouldn't forget pieces. Okay? Just if you struggle to like get all the terms or like make sure you have them all, that's a good way to do it. Okay? But if you're good with the other way, that's fine. I don't know how they taught it to y'all, but that's just how they introed it to us when I took pre-algebra and such. Alright, so that is just basic multiplying polynomials. But now we're going to multiply 3 binomials. Okay? So we'll start out with an easy one. X plus 4 times x minus 6 times x minus 5. Okay? So you're going to boil 2 of them first and then superfoil the last one with it. That's fine. Yeah, you can pick whatever 2 you want. I mean, you could do x plus 4 and x minus 5 if you're just that ambitious and aren't going to lose pieces. So it doesn't matter. So we can put on the x plus 4 and then multiply the other one. So multiplying these other 2, what do I get? Okay, and then now we're back to superfoiling. So what do we get? I heard x cubed. And then you just need to simplify. All right, 34. 2s plus 1, 3s minus 2, 4s minus 3. You good back there? I'm going to be honest with you. If you were to change the variable to an x like every time, like I don't care. So as long as it's a variable that's not like something weird. And as a general rule, the letters that should really be used as variables are like x, y, and z. I would try to stay away from z's because a lot of people make them look like 2's, and it's very hard to tell what's what. So I would say go with x or y. Yeah, s's kind of look like 5's. Mine really do, so you don't want to use like a, b, and c because a, b, and c are usually represent actual numbers. I wouldn't do that either because... And they also need to be lowercase letters, so... Okay, so I would say if you're going to change it, it needs to be to like x. Okay, so if you don't like s and you want to change it, that's fine. When we get to trig, sometimes instead of x, it'll be written as theta, and I often will forget and write the other one. So, anyways. So if you like x better, write it as x. I don't care. So somebody walk me through what to do with this problem. You had S squared, right? I'm just making sure. I don't want you to get thrown off. I know, I was like, I'm lost now. Alright, superfoil. Alright, simplify it. Alright, are y'all ready to try one? I know we only technically did 2 of them, so. Alright. I thought you just said like 5 minutes ago you hated this. Alright. Oh, hold on, I read this problem wrong. 4x minus 1, negative 2x minus 7, negative 5x minus 4. This is as hard as they get. If you can do this one. I mean, I guess you can. I would rather you use x if x is already given to you, but. It can't be A, B, or C. A, B, and C represent numbers, and a lot of times they end up being used in the problem as a number. Like problem 31. Well, problem 31 is actually uses that as a variable, but. Nope, not A, B, or C. I did. You just roaming? Oh.
I did the first 2 on the left first, but now it's 5x minus 4 on the right.
You can do it. That's fine.
Just messing me up on the left.
Alright, do we have an answer? Okay. I'm just going to have somebody yell it out, but I'm going to wait a second. I'm going to... Giving Brooke her 3 seconds. Alright, answer. I have it right, don't I? Think. X was a 2? Okay, do we see if we got it wrong? Do we see where we went wrong?
I messed up completely on my side, but did it the opposite way. My brain wasn't working. It was working like that.
Okay, I'm going to go ahead and give you guys some of the problems. They are not due tomorrow, okay? They will be combined with the rest of this section that we finish tomorrow, which is just like a couple more things. And then if you guys want, rather than you having to watch the video over the weekend, I can record it while you're in here tomorrow. It'll probably take 5 to 10 minutes, and then you guys can not have anything to do over the weekend. Okay? If you want that, I'll do that rather than recording it and having you guys watch it. So, like later. Honestly, it's easier for me if I do it while y'all are in here, because if not, I have to do it later, like after school or something. So, I don't care, but. Alright, so the problems for what we've done so far. Five, 13. 19. 25. 31.